Welcome to today's session. We'll be going through the a mock test, not really a past paper because I can't find past papers. So we'll be going through a mock test, 2021 mock test. So let's get started. So before I do anything, let me set up I haven't set up the Java FX and stuff. So let me set it up now. Hmm. So sudo nada install. Okay, just give me a sec. Then sudo nada install /. Okay, while that's setting, while that's downloading, let me download JavaFX. So download JavaFX. Hmm. So we need to download JavaFX 21, right? So that's what we need to download. So I'm gonna go here and then choose the LTS version, which is the stable version. It's for long-term support. I'm using Linux, so I'm gonna choose Linux, and then I'm using an x64-bit system, and I want the SDK. So there it is. Then I downloaded, and then now it's downloading. And then since now this is done, I can exit and then just search for this terminal. And then let me just continue with Google. Go back, and then there's the terminal. So we're good to go. So let me check something here. Okay, that's not what I'm looking for. So I need to go here, and then appearance. And then blah blah blah. Font size. Let's make it 16 or 18 is fine. I think that's pretty much all I need to do. So now it's ready for whenever I need to set up anything. So my Java FX is finished downloading. So I'll unzip it. So let me do that. So CD downloads ls. So that's everything. So I'm gonna unzip, open that, and then has it been unzipped? Okay, there it is. So let me take my folder, put it under so under the home page, the home directory. So I'm just gonna leave it there. And then now I need to set up my Eclipse. So I'm gonna open my Eclipse and then set it up. So let me open the practical, that mock practical mock test. So there it is. So there's the practical mock test. This was a 2021 mock test, right? So I need to do everything and then backing up, blah, blah, blah. Okay, that's fine. So let's do that. So let me go back to Eclipse. And then before I create a new project, let me set up my JavaFX, right? So what I'm going to do is I'm going to go to I hope I still remember. Where is it? Is it run? No, I think it's window. And then, yeah, window and then preference. And then first thing that I'm gonna do is I'll create the string substitution, right? Strings that I'm gonna need, right, when I'm setting up my JavaFX. So I need the JavaFX path. Basically, where is the JavaFX stored? Which is here, this folder, the lib folder. There's the files, right? Then open JavaFX path. I don't need to give it anything. I don't need to name it, but then it's fine. And then JavaFX modules, which is stored inside that batch file. So I'm gonna go to the batch file, open it with some text editor, and then let me see. And then there's the modules. I copy the modules as they are, and then close, go back to my Eclipse, and then I paste in under the value for the JavaFX modules. JavaFX modules. And then that's pretty much that. Then I go to Java and then build path and then user libraries, right? So I'm creating a library, right? Which will be the JavaFX. So I'm gonna name it JavaFX 21.0.4. And then I'm not sure what's okay. You don't need to select this. I'll just click OK. Let me not select things I do not know. And then I'm gonna say add external jars, right? And then go to my folder and then select all of these jar files, right? Click OK. And then for each jar file, I need to add the source attachment, the source code. So I need to double click on source attachment and then it's gonna show a pop-up. And then I'm gonna click on external location and then external file. Go back here. I need this zip file, which has a source code. So this will be the full path, the absolute path, right? So I'm gonna copy that because I don't want to keep opening that same folder. I just want to paste the location and then paste and then external location, paste, and then external location, paste, and then paste. There we go. And then paste. There we go. And then paste. And then last one, paste. There we go. And then click apply and close. So we've applied, we've set up our JavaFX, we're good to go. So now I'm going to create a new project and I'm going to call it mock test one memo. So it says computer science 2B mock test one memo. By default, just choose JavaFX 21. That is Java 21. So, okay, use the default JRE, and then there we go. Okay, I think I selected something that I shouldn't select. Let me cancel and create again. I just want to double check. Oh, it was still on default. Okay. So make sure you unselect the create module info.java. This one is a problem because you have to, every new class you add, you need to go and change the module info.java to take effect, take that class into account, which is a problem. So let's just unselect it and not create it at all. And then next, and then next. Let me see. Allow output folders for source files. Now just click next, and then this is the end, so just click finish. And then we have our files. Then we can start creating the files. So let's look at how they wanted you to create the files. What classes are expected? If they didn't tell you, then you like what packages should be created. If they didn't tell you, you have to come up with the packages. So data folder, that's where your images will be stored. And then source folder, that's where the source code is stored. And then docs, that's where the batch file will be stored. And then bin folder, that's where it should be left empty, because that's where the binaries are going to be stored. When your code is being compiled, that's where all those files will be stored. So we have this. So we need to complete the server class. This class is responsible for Evo, and then complete the Evo handler class. Registered users are stored in a text file, blah, blah, blah. Okay, so since I don't have all these text files, right, all this information, I will generate it myself. So I'll go, I don't know, wait, I think it's here. Yeah. I'll go to where my Eclipse workspace is, and then there's the project, and then I create the folders, right? So I'm going to create a docs folder for the batch file, and then a data folder. Within the data folder, I need to create a text file. Since I do not have a text file, right? So I need to create a text file. How come it's not allowing me to create? Okay, that's fine. Let me do this. Let me open with the terminal, since it's not showing me the option it's not showing me the option to, what is this, to create the file. Okay, it doesn't want to open with the terminal. That's fine. So Eclipse workspace lscd computer science folder lscd data folder. So now I'm in the data. So I'm in the data folder. As you can see, there's the full path. So now I can create the file, right? I don't know why it's not allowing me to create a file. Yeah. So I'm gonna call it users.txt, right? And then if I list everything, there's the text file. So the text file is now there. What I'm gonna do is I'm gonna open it with Notepad. Okay, seems like Notepad is not showing as one of the options. Notepad++. So let me see if I can open it inside. So let me say open documents. So home, Kiyotaka, Eclipse Workspace, this, and then data, users, open. So there's the folder, right? So I don't know how they want you to structure it. How the users file was structured, but I'm assuming there is. We just have to see. I'll edit once I have more information. Once I've went through the practical. So now what we need to do is we need to I need to get Draw.io to explain what's really going on here. So what are we doing? So what is file input stream, all of those things. So I'm gonna save it on this device, create a new diagram. Doesn't matter what I call it. So we are dealing with so let's talk a bit about what's going on here. Remember, if you watch the video when I was talking about computer networking, that each remember that when you talked about computer networking, each device or an end system is called an end system or a host. Each device or end system or host has a socket. So this socket allows computers to communicate over the network, right? So they communicate via sockets. And then each socket on each device or on each end system has what we call input stream and output stream. So why is it that way? Because TCP, or transmission transfer protocol uses a stream based approach, right, to exchange data. You establish a TCP connection to say that you want to connect to the other end system or device, and then once you have connected to that device, you guys exchange data through streams. It's stream based, and then UDP is the user data protocol, right, which uses the packet based approach. So with UDP, you send packets. Every piece of data that you send it as a packet. So as we're dealing with TCP, so it's a stream based approach, right? You send data via streams. So by stream based, you just mean that you send or receive data via streams. So when we receive data, so when you receive data, right? When you receive data, you receive it, you receive data via the input stream, right? Via the input stream. And then to send data is the opposite. To send data, you send data via the output stream. Why output stream? Because it's meant to be sent out. Receiving, you're meant to get input. Data needs to come in. Data needs to come in. Output, data needs to go out. Coincidentally, which makes sense. That's why sometimes Java is good, because it makes things simple. Coincidentally, the classes that you use to access the input stream for that, remember we send via the socket. We communicate via the socket. So this stream, this input stream is accessed via the socket. So you access through sockets, because computers communicate via sockets. You might want to skip this section and not pay attention to what I'm explaining. That's up to you. It's your own funeral. But then this is very important knowledge before we start coding, so that you realize that you don't have to cram code. And then here you access this, you do the same thing, access through sockets. Because each device has a socket, interface. It's actually called a socket interface. So each device has a socket interface which defines how it receives data from another computer and how it sends data to the other computer. So basically, everything is communicated via sockets. And remember what I told you about sockets. It's like on each endpoint or on each device, it's like a cup. One device can be sending, when one device is sending, the other one is listening. So it's like a cup with, let me say, cups with a string. If you remember this thing, right, even though we might not all have the same like background, but then you know very well that when you take these two cups, right, this is a perfect example. As you can see, imagine each cup is a socket, and then this line over here is the stream that we communicate via. So when this person is communicating, the other one is listening. So this one is going to communicate via the socket or this cup, and then the data will travel. But then the stream actually travels in terms of bytes. So you're going to have a set of zeros and ones traveling to that side. We pass those streams, that input stream or output stream, via classes that help us interpret these zeros and ones as primitive types. We'll talk about that now. So it sends bytes, right, zeros and ones to the other device or the other person, and then the other person listens, and then they check in their input stream. So when this person is speaking, it gets sent out via the output stream because it's being sent out. And then when this person receives this information, it's being received via the input stream because those bits or those bytes are being received via the input stream. As since this is input, this is incoming data. So I hope that's pretty straightforward. So coincidentally, we have a class called input stream, and then we have a class called output stream. But then remember, there's streams, right? It's in terms of bytes or bits, binary digits, however you want to interpret it. It's in terms of bytes and bits. To get the actual data the way we want in the form that we want it in, we would have to, what is this? Wrap around, right? So we have to wrap around using classes that help us interpret those pieces of data. So what I would do is I'll just let me save my document. Yeah, I'm running Notepad++, which is let me do this. So I'm gonna call it notes.txt. So I'm running Notepad++, which there's this other program called Wine, which helps me run Windows applications on Linux. So I'm running it through that. So that's why the folder is very far. It's far to find the folder. So we have input stream, which is in terms of bytes and bits, which is the normal, which is like the standard form of the streams. They transfer bits or bytes, zeros and ones, right? So since I would actually actually say bits, not necessarily bytes. Let's say bits, which is binary digits, zeros and ones. So let me phrase it properly. Let me say bits. So it's in bit form, right? Which is a binary digit, 0 or 1, which is basically 0, something like this, right? Zeros and ones. But then it's a problem for us people because we have a language, right? So we need to wrap around these these um these bits of data, right? These zeros and ones, so that we can be able to read them. So that's why we have classes like input stream reader. So input stream reader, right? All it does is it helps us map each not necessarily each bit, I mean, but then I would say each byte to a character set, right? So that's basically we interpret these zeros and ones in terms of strings. That's what this class does. It helps us do that. As you can see, it's input stream reader. It reads our input stream, which is which is in terms of bits. We read that input stream and interpret it in terms of character sets or strings. Remember, there's two ways of file handling, right? There's text-based and binary IO. So if you want to communicate in terms of text, you have to use input stream reader. But then the text can come in multiple times. Like we can have a lot of text. So to speed up, to make it a bit faster, we use a buffered reader. Basically, we buffer the text or the string. We store it in a buffer. We can use the buffered reader for that. And then the last thing, if we wanted to write out the data, right, we can use print writer, which helps us write text or a string and to write out text or a string to the output stream. So this is when you are communicating with the other device in text form. So you send hello to the other device, and then the other device says, "How are you doing?" That's in text form. it's mainly based on text. There's nothing but text. You only text. It's sort of like texting, right? Remember when you're texting, you send text. So this is like sort of like texting in WhatsApp, sending text and receiving and receiving text. That's pretty much where you use these classes. We definitely going to use them because if you check the practical, they said you should send this command, greetings and the name and password. So you see you're sending greetings. So it is text. So that's why we're going to need the print writer, because a writer helps us send text, right? It helps us write or send text. So in other words, the input stream reader is going to um, help us read the bits in string form. That's mainly what the input stream reader is for. And then the buffered reader is just to buffer the strings that we've read to speed up the process, to make it faster to read from the input stream. And then this one will help us send strings, or send strings to the output stream. And then that's pretty much that. And then remember, there's two ways with file handling that you, in terms of files, right? There's two ways of writing to a file. You can write to a file in terms of um, you can write to a file in terms of text based, right? Like text, as you can see right now, I'm writing text. Or you can write it in terms of binary, binary, which is basically bits, zeros and ones. So zeros and ones. As you've seen in the, if you didn't see, I suggest you go read the textbook again, because you'll understand all of these things, especially file handling, the Computer Science 2A textbook. So when you're dealing with file handling, like text based is usually slower. Why is storing creating a file and storing the information in text slow? Because there's two things that go into place: there's encoding and decoding. Why do we need to encode and decode? Because we are not storing it in the actual language of the computer. We're storing it in our own intermediate language. That means there's a translation that goes in place. So these two things just means translation, the encoding and decoding. So encoding is just basically you take in the ASCII, you take it in terms of in the string form, right? You take in the string form and then convert it to bits, then convert to bits. And then decoding, it's vice versa. You take in the bits and convert to string. And then the string, we usually use ASCII or Unicode for that. So you see, when you're dealing with text files, they are slow because it always has to translate. So when you double click, what does it mean to translate? So when you double click like this, right? Let's say I double click this file and then I want to open it. There it is, it opens. It's going to show me text, right? Okay, let me put in a name here. So let me use the example. Remember, we need to create a user file, right? So I'm going to say buggy, right? Call it buggy. That's the user. That's the only user we have. Control S to save. So let me close the file. As you can see, the batch file, actually, even the batch file was fine. So what happens is when I'll double click a file and it opens and it's showing me in text form. You might not understand and be like, why is it showing me in text form? So what happened is it decoded under the hood. Remember, all files are actually binary files. The only difference is that there's some files, like text files, that have decoding and encoding in them. So it was stored in terms of bits, zeros and ones. Then when I double clicked it, it did what we call decoding. It decoded, it took in the bits that were saved and it converted it to string because you saved it as a text file. So that's why I can now interpret it in terms of this. And remember, when you decode, you're simply mapping each you take in each bit or each number and then convert it to its equivalent code, to its equivalent character. There's this thing called ASCII table. Remember that numbers under the hood, or characters under the hood, are just numbers, integers. So as you can see, there's the ASCII table, right? So a new line character is actually the integer number 10. But then remember, computers only use a set of two values, zeros and ones. So it won't store it. You won't store it in DEC. It will store it in binary form, which is zeros and ones. Not necessarily zeros and ones, but then you can view it in terms of like that. That's sort of like the easiest way of picturing binary. So a space, a backspace is 32, integer number 32. So you see that it's a long process. Since there's ASCII code, this is what happens, right? Let me show you what happens. So let's say you type in, okay, let me show you. Let me choose a different, yeah. So let's choose a lowercase letter a. So let's say you had saved in your text file, it was encoded as a, right? By encoding, it means it took in the string form and was converted to bits. So to convert that, it needs to convert it to an integer first, which is a decimal format, but then binary, computers store in things in terms of bits, which is binary digits, set of zeros and ones. So this gets converted to a set of zeros and ones, like this. Then now it gets saved like this. Then now when you decode and you double click on a file and you want to view it, whether it's an image or whatever file that is, there's decoding and encoding always. You just don't know it. So it takes in the bits, the way it was saved under the hood, translate it to an integer, and then it goes back to the small letter a. So you see this whole long process here of translating, going from this, it makes the text files slow. That's why binary files are advisable. It's advisable to use binary. But then the problem with binary is that you have to create a program. You must create like a Java application or a C++ application in order to read the bits, because you are not a computer. You don't speak the language of the computer. You want to view it in terms of string form. And then the text files are helpful for us human beings because I can just open a program like Notepad++ and double click, and then it's going to do the translation for me. So in terms of binary, we tend to use binary a lot when transferring data over the internet, right? Why am I saying so? Because that's how it is. You see, input stream, bits, zeros and ones. So we need to actually make use of classes that help us to send data. So we're gonna use this classes data input stream, and then this will help us send data to the input stream as bits, right? We are sending it as bits. Remember this top part, you're sending it in a string form as text, like a text file. Now we're sending it as bits, and then the data output stream. We're receiving, my bad. Input, you're receiving. You receive the bits, right? You receive the bits via input stream, and you interpret them as primitive types, right? You interpret them as primitive types. So as int or string or float, that's how it's going to be wrapped around. So interpreted as that. But then no, let me see. Yeah, I'm right. It's going to be interpreted as that. And then output, you send bits via the output stream. You send those bits as primitive types. So you can send a byte, a short, an int. You can send all of those primitive types, right? A byte, a short, or an int, yeah, you can send a byte, a short, an int, or a float, or a double. You can send all of these types. There's more like char. There's a lot of types. Char, all of them. You can send them. You can send. It will interpret them as bits, but then you'd send them in this form. But then the other side will receive it in bit form, in terms of zeros and ones, which is quite effective. So this approach is way faster than the other approach. So once we have these classes, data input stream and data output stream, that will help us to handle all of that. And another class, classes, the other set of classes that we need is the file input stream. So the file input stream helps us to read the bytes from the image. And then file output stream helps us to write bytes to the image. So basically, it helps us make changes to the image. By writing bytes, like you changing it, for let's say for example from grayscale to from from an RGB to grayscale, something like that, you are manipulating the image. These are needed because we need to be able to upload and download. Uploading and download just means you are sending data. If you check very closely, the code will actually be the same for the upload and downloading. The only difference is who's doing what, who's sending what data where. That's the only difference. If you are receiving data from, if you are receiving data from the server, we call that downloading. If you are sending data to or an image to the server, we call that uploading. Don't you click upload on Google Drive when you're uploading an image? And then haven't you wondered what it does? We're actually going to write that code that it has under the hood that helps you upload the image. So I hope that makes sense. Let me check how much time I've covered. Okay. So we're still on the right track, 39 minutes. So we're going to need all of these classes, right? They're going to be very important. And remember that when we dealing with TCP, right? TCP, well, you can use the socket class to create a client socket. And then you can use the server socket class to create the server socket. I mean, it's in the name, server socket. So since we have the client and the server, so the client in this case, how can you view a client? What would we say is a client? So a client is like, for example, I click code blocks like this and I run it. The person who is currently open code blocks, which is me, in this case, is a client. I'm using the services of code blocks. In this case, code blocks is the server. It's responding to my actions. For example, if I click the close button, the server responds and then it closes that app, right? So I would be a client in that scenario. So all of these classes are going to be needed. We're going to use them. They're going to help us a lot. So let me open this app now. So we are done with that. Let me go back to the project. So now let's see the classes that we need. I don't know. I don't have the code that was written there. So I will just write it from scratch. So that's how I'm going to do it. I'm going to write it from scratch. And it seems like you already had, yeah, I think in this one you already had the GUI. You must use the JavaFX library for your GUI. The class will provide blah, blah, blah. So we need to create all the classes, right? So what I would do is I'll create the packages for each class. So this is normally how you would do it. Even on your side, this is normally how you should do it. The package for client code, right? Basically code that represents a client. You put it, even the main, its main. Remember we're actually building two systems, two applications here. Both of them needs to have their own main function. So the package for client code would be, you'd say AXI for the academic of software, of computer science and software engineering, right? AXI dot computer science CSC2B dot client. And then the package for server code, it's the same thing, you just change client to server. So argc.csc2b.server. So this is how I'm going, this is where I'm going to put all of the classes. So let's start now. Let's start by creating the classes and see how far we can go. And then just remember what I said. Let me go back to draw.io. Just remember what I said. Each device, right? You're going to have a, let me double check something here. Where is it? Okay, it's not there. Let me just edit. Let me say AWS 3D. Okay, that's not the one. Material design. Nope. Definitely not the one. Then that's electrical engineering, this one. And then info. Where's the one? This is the one that I'm looking for. Okay, let me see Android and see. Okay, that's not the one. IBM, let me look for IBM. I think IBM should have some of these things. Where did I find it last time? Last time I was able to view compute. Okay, I think it's network. Yeah, I want these computers to be able to illustrate to draw the diagrams. So I'm gonna close all of this, close, then close. Where's the network here? Oh, I didn't select it. Okay, so I need to select it and then apply. Okay, there it is. So now I can use the computers to demonstrate, right? Because we're doing computer networking. So let's say this is your device, right? So this is your computer. I feel like it's best to have diagrams for these things so that you can understand the code. So this would be your computer, right? And then there'll be another person's computer. And each computer, like I said, it has a socket, right? So I'm gonna create a socket on each, and then each socket has an input stream and an output stream for receiving and sending data. It's that simple. And then remember we talked about the cups with the string. Each cup in that example will represent the socket. And then the strings will represent the streams where the data travels, whether you are receiving or you're sending data. So I don't know which diagram to choose. Okay, let me just choose this one. So each computer, each device will have its own socket, right? And then text. And then I need to enlarge the text. I'll make sure I include the diagram when I upload the videos. There's going to be multiple parts. I think I should just make at least two parts, right? So this will be a socket on that device on that end, or I can just do this. I'm just wasting time. I could just do this. Just enlarge the text and then color it in to make my life simple. And then this would just set it to blue and then copy paste. This side will also have its own socket. Let's just use a different color to show that these are different devices, right? Yeah, okay, I can change the color. So you see, these are different devices, right? Each device has a socket or a socket interface that allows you to communicate, send and receive data from another socket or another device's socket, which is very important because how else can we communicate? And then, like I said, each device in turn has an input and output stream. So we're gonna have this. So if the way I'm gonna draw the diagrams, right? If it's facing that way, it's an input stream. If it's facing that way to the right, then it's an output stream. We are sending out data. So that's how I'm going to interpret it. So both of them have their own streams, right? And they're linked to the socket. So if you send data, so I'm gonna copy this, paste it, then put it here, and then copy, paste, put it there. Yeah, so this one will be output because it's facing the other device. This one will also be output stream because it's facing the other device. This will be input stream, it's facing that way to show that it's receiving. You can think of it as tunnels, that's up to you. I don't care how you view it as long as it makes sense to you. So I'm gonna put a label here to explain. Okay, I'm gonna put it on top because within the, okay, it's fine. Yeah, it's fine. Let me put it at this end. This would be the input stream. And remember, the input stream is the input stream for that socket. That's why when we create a socket, we say socket.get input stream. So this will be input stream, and then there we go, and then this, and then I'll also do the same thing. Okay, not this, I want the text, and then I'll put the text there because this is also input stream, and then I'll put the text here for output stream, and then output stream, since we're sending out data. And then I can give them colors. I'll just stick to that convention, right? Blue for the other device, and then the pinkish color or the reddish color for the other device. No, not the text, the stream itself, the diagram. There we go. There we go. So what happens when you want to send text, right? So this is what happens. So let me make an example of what happens when you send text. So it depends on which stream are you using. Are you using the data input stream, or are you using like a print writer, which is going to send it in text form? It just depends on how you send the data. So in my case, I would just assume you send it in text form. Let's just assume it did that. So this is linked to your socket, remember? So they're all linked together like this. They're all linked together. So let's say you wanted to send out information, right? How would you send out information? It's simple. Remember what I said, output stream is for sending, input stream is for receiving. That means this device, the pink one, I don't know what color that is, or the maroon. I don't know whether this kind of looks like maroon. This device, right? We'll call this computer A. So let me just put text there at the top and say this is computer A, right? So computer A or B. So this is computer B, and then we have computer A. So computer B, when it sends data to computer A, it sends the data via the output stream. Then computer A receives the data via the input stream. So let me make an example of what data. Let's say you wanted to send this user wanted this computer wanted to send out the message hello computer A. But then before they can communicate, right, there's this thing called a TCP connection. It needs to establish a connection. So for that link to be established, basically the link between the sockets, for them to be established, the link between the sockets, computer A will send a message. Computer A, I'll just say comp A will send a message and say, hey, anybody there? To ask if the server is there. So the server would then, or the other device would then send a response to this device. And if the person received the response, then they know, okay, we can establish the connection. So I'll shade the color to show you who's sending that message. So this one is coming from this computer A. Hey, anybody there? So remember, they're trying to establish a connection. So let's say that line is not there yet. They haven't connected. And then the server is always listening for incoming connections. So what the server would do is it's going to send a response, right? Or it's going to accept that connection. So comp A, oh, I'm mixing up things now. This is comp B. This one is comp B. Computer B, comp B, and then this is computer A. So let me copy it again. And then comp B will say, I'm here, right? Something like that. I'm here. I accept, right? We'll see that we have a method called accept. I accept your attempt to try to connect with me. I accept that attempt. So you can connect. When it receives a response, it knows, oh, so now I'm connected. So therefore I can connect. Then now they can connect. So now the sockets become linked, right? The sockets are now linked. They can exchange data via the sockets. So this one can send via the output stream, the other one can receive via their input stream. So now the devices can connect or communicate. So this will be there, and then, so these two things are linked to the socket. So let's show an example of you sending out data now. So remember, sending out data, send it out via the output stream. That's why I put I made it face that way, because the text is going to come out in that form. But then it's going to come out in terms of zeros and ones. So let's say your message here, it's in bits, remember, it's always in bits. So you're going to send your text here to say, let's say, for example, greetings command. That's the text you're sending, right? And you'd have to use a print writer, because what did he say? When you want to send text, you use a print writer. If you want to send it in terms of primitive types like integers, but then at the end of the day, it's going to be in bits. It's going to be received in bits, in bit form. Then use data output stream and data input stream. So let's say this is the message, right? You want to send greetings. So this greetings, it gets sent as it is, because we're using text base. That's the problem with text base. So it doesn't get sent as it is. Yeah, it gets sent as bits, but then when it gets to that side, those bits need to be translated or decoded. And then remember, they get received via the input stream of the other one, because the other one is going to treat it as this is incoming data. This is input. But then the other device it views it as output, since it's sending out data. So that greeting will be encoded, basically translated to zeros and ones. And those zeros and ones travel, and then they get received by the input stream of that socket. After it receives those binary digits, zeros and ones, it still needs to translate them, because remember, it received them in text form. It needs to still translate them to that actual text that was sent by the user. So that's when decoding takes into place, which is why it's generally slower to work with text files. And the other ones are easy. The binary files, it's more efficient. And then it gets translated back to greetings. So it went from this, it gets transferred as bits, and then when it got to the input stream, we wrapped around, right? we passed it via the input stream reader to translate those zeros and ones to greetings. That's pretty much the flow of data. That's how we're going to do it. Even images, we're going to use file input stream to read the bytes from the image, and then we use data output stream to send out bytes, those bits via the streams to that other device, and then that other device is going to receive those bytes via data input stream, right? Because they were sent out via data output stream. They're going to receive it via data input stream and then send them to the file. Those bits, they get sent to the file. So it's technically, when you say uploading and downloading, you're just transferring zeros and ones from one file to another file. So this is the typical communication, how it works, the communication between the two devices. I hope it makes sense. So let me see how far I am. Okay, it's almost an hour. Yeah, you might skip and be like, yeah, let me skip. It's not worth it. Let me skip. Yeah, and then you're gonna fail dismally, and then we'll be laughing now. So I suggest you watch the full video. So I'll stop part 1 here. This will be part 1, and then I'll just upload the notes and the. Okay, it's fine. You might watch or just upload all of the videos at once. So I'll just end part 1, part 0 here. I'll call this part 0. So thank you. See you in the next video.